Imagine you're tracking a plane in the sky, but instead of just looking at it normally, you blink your eyes half a second at a time. That might sound like a stupid idea, but that's exactly how a traditional camera works. A traditional camera, or a frame camera as we'll call it from here on out, works by taking a full frame image at regular intervals. For example, a 1080p camera with an FPS of 30 will take a full frame image every 33.3 milliseconds. For most use cases of a camera, this is perfectly reasonable. However, there are certain problems that become computationally inefficient with a frame camera. This is where the namesake of our project comes in, the neuromorphic camera. Just like our eyes, the silicon retina of a neuromorphic camera works by taking events instead of frames. The event camera will send an event when a change is detected in the scene, instead of sending the entire scene at regular intervals. With this new style of data, there are unique new ways of solving existing problems in computer science. However, this does not come without its drawbacks, the biggest one being that the data is not easy to visually reason about, like with data from a frame camera. This is where NOVA comes in. By taking in a range of events, we can construct what a frame-based camera might have seen, which is something that humans can visually reason about with ease. We call this method digitally coded exposure. By using the GPU to accelerate computations, we can construct frames with millions of events. Here we can see the 3D visualizer displaying the raw event particles, the negative and positive contributions, and it's pretty hard to reason about as a human. You can kind of tell some trends in the data. However, whenever you switch to digital coded exposure, the data becomes really clear. You can even make out the details of what types of cars are passing by and the bus that's passing by as well. Our support of live streaming data from physical cameras, along with supporting features, mark the end of our capstone project. However, the story of NOVA does not end here. Los Alamos Laboratory has suggested that NOVA may be fully open source in the future, and would love for researchers interested in neuromorphic cameras to help advance NOVA further.